Hi friends, in this particular video I am giving you briefly how DAC is present, what is exactly DAC, okay, so what are the various pins of DAC, what is DAC generally, it's a digital to analog converter, okay. Let us see what is exactly DAC and how many pins are present and what is the function of each pin, we'll see detailedly, okay, in this particular video. See here, so we have many DAC ICs are available. Now let us see one DAC IC, call it as DAC 0830. I will highlight. So IC number is DAC 0830 is one DAC. Let us see what is the role of this DAC IC. Okay, how many pins are present. Okay, let us see what is the functioning of each pin. We'll see detailedly. Here first of all, now this DAC 0830 is having 20 pins, total 20 pins, 10 in one side, 10 in other side. Like that we have 20 pins, 1 to 10, then 11 to 20. So we know DAC it's a digital input and it will makes digital input into analog output. Like that we have some idea, right? Digital to analog converter. With the help of DAC only we can observe how we are converting digital data into analog. For example, I need to generate analog triangular wave or sawtooth wave or square wave, then what happens? We are writing program in the processor and we are getting the digital nature of the waveform, and that waveform is given to DAC. Then DAC converts the digital data into equivalent analog data or equivalent analog waveform. For that, the DAC is very much essential. So in which way it will convert? Okay, let us say detailedly here. So DAC IC number is 0830. So in that DAC there is a starting point purpose. He mentioned like a one indication. So it indicates that we are considering pins start from this particular side. Okay, sometimes they will be given like a curve. Okay, based on curve, okay, left side of the curve indicates starting pin and the right side of the curve indicates ending pin. Whereas here dot indicates from this side where starts the pins. Like that there is identification. So coming to here, let us see 1 to 10 and 11 to 20. In DAC also we have 8 digital pins. See here pins DI0 to DI7. See pin number 7, okay, 6, 5, 4 comes like a DI0. What is DI0? Digital input pin. D indicates digital, I indicates input. DI0 is a digital input LSB bit. DI7 is digital input 7th bit, that to MSB bit. Like that we have 4 digital pins in the left side and 4 digital pins in the right side. Total DAC will take 8 digital inputs. Okay, 8 digital inputs. DI0 to DI7. Similarly, DAC having 2 grounds, 10th pin is ground, 3rd pin also ground. Why 2 grounds? Because DAC one side is digital, other side is analog. For that we need 2 grounds, digital ground, analog ground. For that reason we have 2 grounds, pin number 3 and pin number 10. Then we have CS bar signal. We know what is CS bar is a chip selecting signal. It's also present. Then 2 write bars are present. Write bar 1, WR1 bar, WR2, and VCC. It's a power supply pin. ILE, one pin, call it as ILE. Okay, input latch enable. Then XFER bar, transfer control pin. Okay, then 2 output currents, IOUT1 and IOUT2, pin number 11 and 12. Similarly, 8 is V reference voltage, and RFB is feedback resistance. Like that we have pins. Okay, naming. Let us see functioning of each pin. So coming to first CS bar. So we know what is CS bar, it's a chip selecting signal. So what is the role of CS bar? So first and foremost function is whenever CS bar is activating, then only DAC will take digital data and converting it into analog data. So CS bar is essential. Who will activate this one? CS bar is activated with the help of external decoder, okay, or with the help of processor. Directly processor will also activate CS bar, or external decoder will activate CS bar. Then only it will convert digital data into analog data. Okay. Now other is CS bar is also used along with ILE signal in order to activate WR1 bar. Consider CS bar pin is also used along with ILE pin for activating which signal? WR1 bar. Okay, in order to activate this WR1 bar, which are very useful pins, CS bar and ILE. These 2 pins are used to activate WR1 bar. So CS bar performs one function in addition to ILE, or along with ILE, the CS bar will activate WR1 bar. Okay, like that we can write description of CS bar. Coming to WR1 bar. WR1 bar is a write 1 bar signal. and this signal is activated with the help of CS bar and ILE pins. These two pins are used to activate WR1 bar. That is one point on WR1 bar. But the second point, whenever WR1 bar is activating, then digital input data is loaded into input register. So whenever WR1 bar is activating, the digital data is loaded into input register or input latch register. There is one register called it as a input latch register. That register now receiving 8-bit digital data whenever WR1 bar is activating. And who will activate WR1 bar? This WR1 bar is activating with the help of CS bar and ILE pins. Coming to ground, here we have to ground 3 and ground 10. These two grounds, one related to digital and other related to analog. And grounds will provide protection against digital problems as well as analog problems. So grounds will provide protection against the overcurrents in the digital side as well as in the analog side. Further, we have two grounds. Then DI0 is LSB bit and DI7 is MSB bit. So the DAC 0830 contains 8 digital lines DI0 to DI7. So all these digital pins are used to receiving the data from the any of the digital device, maybe from the Prasad data bus. Okay, now these 8 data lines are connected to Prasad data bus, or these 8 data lines are connected to any of the port of 8255. So DAC will receive data from any of the digital device, which include 8086 or 8255 or any other digital data. From those digital data, DI0 to DI7 bits are used to receive data. Then later we'll see these two. We'll go to this side. Now other important point is ILE. What is ILE? It is a input latch enable. Input latch enable. So this input latch enable is a one pin and it should be high. Okay, then only it will activate. And this ILE is used along with CS bar signal for activating WR1 bar. Okay, this ILE is mainly used for activating which one? WR1 bar. Then only WR1 bar is activated, then only digital data is loaded to input latch register. Okay, for that purpose ILE is required. ILE is required only for activating WR1 bar with the help of CS bar. Then coming to WR2 bar. WR2 bar is another write to bar signal, and this signal is activated with the help of XFER bar. So this WR2 bar signal is activated by using XFER bar. What is the name? It's a transfer control pin. This pin will activate WR2 bar signal. So whenever WR2 bar is activating, then digital data will move from input latch register to DAC register. There is a DAC register where the digital data is converted into analog data. So when a DAC register receiving data only by activating WR2 bar. So whenever WR2 bar is activating, then data will move from input latch register to DAC register. Okay, in WR1 bar what happens? Input digital data is loaded to input latch register. Whereas WR2 bar is activating, data will move from input latch register to which one? Input latch register to DAC register, where digital data is converted into analog data. And this signal is activated with the help of XFER bar. XFER bar is a transfer control pin. Now let us see what is XFER bar. Only one function is this signal or this pin is used to activate only write bar to signal. For that purpose only we are using, and this pin is activated by using processor commands. Based on the processor or 8086 processor will activate XFER bar, and accordingly XFER bar will activate WR2 bar signal. Whenever the signal is activating, data will move from input latch register to DAC register. Okay, so now what about other two, IOUT1 and IOUT2? Generally this DAC will convert input 8-bit digital data into analog output current first. We don't get directly voltage, we get only output, analog output current, IOUT1 and IOUT2. So for example, all digital bits DI0 to DI7 all are ones, then we get maximum output current. Okay, for example, some are 0, some are 1. Accordingly, IOUT1 is in the range from minimum to maximum. So, but we have IOUT1 plus IOUT2. Sum of these two currents must be equal to constant. Like that, the DAC will convert the 8 digital inputs data into analog output current, IOUT1 and IOUT2. So these two will be connected to externally operational amplifier, plus and minus. Okay, so plus, for example, plus connected to IOUT1, minus will connected to IOUT2, and IOUT2 may be connected to ground. Like that also we can connect these two currents to operational amplifier. Okay, now RFB. What is RFB? It's a feedback resistance. Now now this feedback resistance is connected to shunt part of the operational amplifier in order to make these two currents into voltage signals. So why we use a shunt feedback resistance? RFB is a shunt feedback resistance pin, and this RFB is connected to shunt feedback resistance of operational amplifier, and accordingly we get the analog output currents into analog output voltages. For that we are using RFB pin. This RFB is now connected to shunt feedback resistance in the operational amplifier for making currents into voltage, output voltage, analog output voltage. Then what is other one? VREF, nothing but it's a reference, analog reference voltage. So how much analog reference voltage we are generating, we are giving referencely with this value. Generally this VREF is an analog reference voltage in the range of plus 10 volts to minus 10 volts. In that range, DAC easily converting the digital bits into equivalent analog output voltage in the range of plus 10 volts to minus 10 volts. Okay, for that V reference should be connected to in the range of plus 10 volts to minus 10 volts. Okay, this V reference pin is connected to analog reference voltage in the range of plus 10 to minus 10 volts. Like that, RFB is the feedback resistance, and it is connected to shunt as a shunt feedback resistance to the operational amplifier for making analog output currents into voltage. Okay. Similarly, VCC is a power supply pin, and this DAC receiving a DC power supply in the range of plus 5 volts to plus 15 volts. For optimal operation, we should give you 15 volts DC supply to pin number 20. Okay, VCC is a power supply pin, and this pin will receiving voltage in the range of plus 5 to 15 volts. For optimal operation, we should give you 15 volts DC supply to VCC. Okay, this is the pin description of DAC 0830. Simply DAC takes 8 digital inputs and converting into analog output current, IOUT 1 and IOUT 2. Depending on the bits, IOUT 1 current must be maximum or in the range of minimum to maximum. For example, all digital bits are zeros, then IOUT 1 is minimum. For example, all digital bits are ones, then IOUT 1 becomes maximum. So the sum of IOUT 1 plus IOUT 2 should be equal to constant. Okay, and in order to make these analog output currents into voltage, here we are using a feedback RFB, feedback resistance pin, and this pin is connected to shunt feedback resistance of the operational amplifier. Then we get currents into voltage, and this is a reference voltage, and this pin should be connected to plus 10 to minus 10 volts range. Okay, and this pin connected to analog reference voltage. With that voltage we can generate. Now CS bar is a chip selecting one, and WR1 bar is activated with the help of CS bar and ILE, and ILE is essential for activating WR1 bar. Whenever this signal is activating, data will move from the digital data is loaded into input latch register. Whenever WR2 bar is activated, data will move from the input latch register to DAC register, where data is converting from digital into analog. This signal is activated. This signal is activated with the help of XFER bar. Okay, XFER bar is activated with the help of 8086. Okay, like that we can analyze the pin diagram of DAC 0830. Okay, in the coming video, okay, we'll see how DAC 0830 is interfacing with 8086 microprocessor detailedly. Okay, I hope you understand the pin description of DAC IC. Okay, if you really like, please kindly share my video to your friends and subscribe my channel. Okay, thank you so much.